Hello everyone, and welcome to a little video demonstration here. In this video we're going to talk about energy and whether it is conserved or not. So those of you who might not be familiar with the video game genre stuff, this is Portal, and what I've got here is I've got quite a few blocks, and they're at rest right now on these light bridges. I guess pretty cool little sign, just a little wave there. But anyway, and so what I'm going to do is I've got a button over here that I'm going to push, and all of the blocks, or all of these light bridges, are going to cut off simultaneously. Now, this blue portal here represents the entrance, and so right now they would pop up out of there, but we want them to go over there. And so just a quick little demonstration. Anything that goes through the portal comes out right here. And so basically they're going to go through there, and they're going to come out of that orange portal as a horizontal projectile. Now if you look, we have a gradual increase in height as we go. And so if you think about conservation of energy, starting out they're only going to have potential energy. And so what I want you guys to do is come up with an equation for how far, in other words, how far, or the horizontal distance that those blocks are going to travel. Okay, so think about it. You've only got initial potential energy, and then if you think about it, that initial potential energy should equal the amount of velocity that it has right when it goes through that portal. Okay, so here we go. I'm going to stop time real quick, pretty cool, and kill these switches. Okay, so now all of my light bridges are gone, except this one down on the bottom, but that's for a different demonstration. Okay, so let's take a look at this, and let's watch it in normal speed. So here we go. Pretty, right? Now, if you notice that, and we'll go ahead and restart real quick and we'll watch it again in slow motion. But if you notice that, you should have seen that the first block came through. Obviously, it came through with the lowest speed because it had the lowest, or excuse me, the shortest horizontal distance. But the blocks that went through after that, we're going to watch it again in slow motion, but the blocks that went through after that didn't quite add up to me. Let's put it right about there. And here's why. We'll watch it again, and we'll watch it again in kind of slow motion, but you'll see that at the end, the blocks kind of stack up on each other. And if energy is being conserved, then the, let's see how fast I want to do it. Let's do it at 10%. Okay, so let's clear our timer. If energy is going to be conserved, then all of those blocks should end up with this same type of pattern. In other words, we should end up with a very parabolic shape, but we don't. We end up with them stacking on top of each other. So let's watch this again. So now we're at 10% normal speed. So you see they're all starting to fall, and the that block is already through. And let's go about half speed. You see, there we go. They end up nice and far apart, and then they all stack on top of each other there at the end. So think about what that means in terms of energy and what must be happening to the blocks while they're on their way down.